Let's get some practice with true formulae. Before we do so, let's just make sure you do understand what the difference between true and empirical formulae are and how we get that. Pause the movie while you fill each of these gaps in. This is what you should have got. Percent composition gives us a mass ratio given in the format of a percent, in other words, the total being 100 grams. And that mass ratio can actually be measured. It is empirical. Empirical means you can measure it. By converting it into a particle ratio, we get the empirical formula. How do we convert it to a particle ratio? How do we convert a mass ratio to particle ratio? We use the periodic table. We use the molar mass, which is inside the periodic table. The empirical formula gives us a particle ratio in the simplest form. So if you add the molar masses according to that ratio, you will get the simplest molar mass. But now the problem is that sometimes that molar mass is not really the molar mass, that simplest molar mass. It's not the true molar mass. It's not actually how many grams a whole mole of that substance would really weigh. So sometimes you find a difference between the molar mass that this empirical formula gives you and the true molar mass. And when there is such a difference, you must find the factor, let's call it X, by which they differ. How many times the true molar mass is greater than the simplest molar mass. And then adjust the empirical formula by that factor to get the true formula. So let's get some practice with that. We are told that a 2,012 gram sample of compound, that's the mass of the compound as a whole, it's composed of so much nitrogen and so much oxygen. Note that if you add these together, then you will get that mass there because that's the total. So this information gives us the mass ratio of N to O within this compound. We can convert that to a mole ratio and get the simplest formula from that. Then it tells us the molar mass of the substance is so much. You must get the true formula. So what do? The first step we must do is use that information to find the empirical formula. Then secondly, from the empirical formula, we must get the simplest molar mass. Then we must compare that to that which we've been given, the molar mass, the true molar mass. Compare, and you will find either they are the same. If they are the same, the simplest and the true molar masses are the same, then the empirical formula is the true formula. But if you find that they are different, you must find the factor by which they are different and use that factor to multiply everything in the empirical formula by to get the true formula. So those are the steps in calculating true formula. First we get the empirical formula. Then we compare the simplest molar mass, which it gives, to the true molar mass and convert the empirical into the true formula from this comparison. So our elements are nitrogen and oxygen. The mass ratio is 0,5219 grams of nitrogen for 1,4901 grams of oxygen. We need to convert this mass ratio into a mole ratio, a particle ratio. How many moles of nitrogen have a mass of 0,5219 grams? We use the molar mass of nitrogen as our conversion factor, making sure that grams are at the bottom and moles of nitrogen are at the top. We know from the periodic table that 1 mole of nitrogen has a mass of 14 grams. 0.5219 divided by 14 is 0,037 mole of nitrogen. How many moles of oxygen? Notice mole of nitrogen atoms, not mole of nitrogen gas, not N2. Same here, mole of oxygen atoms. Do we have when we have a mass of 1,4901 grams of oxygen atoms? We use the molar mass of oxygen atoms as our conversion factor. Again, making sure that grams are at the bottom so we can cancel grams away, and mole of oxygen atoms at the top. From the periodic table, we know that 1 mole of oxygen atoms has a mass of 16 grams. 1,4901 divided by 16 is equal to 0,093 mole of oxygen atoms. So this is now a particle ratio, a mole ratio, but it's not in its simplest form. So we still need to simplify and possibly multiply because we need a whole number, ratio in its simplest form. So we take the smaller of the two numbers and we divide through everything by it. 0,037 divided by itself, because it is the smaller of the two numbers, obviously is equal to 1. 0,093 divided by the smaller number, 0,037, that gives us 2,5. So now we've converted this ratio, 0,037 is to 0,093, into a nicer format, but it's still not got only whole numbers in it. So now we need to multiply. We multiply everything by 2 to get rid of that fraction. 2,5 multiplied by 2 is 5, and obviously 1 times 2 is 2. And here we now have the empirical formula N2O5. So we've done the first step. We've got the empirical formula. The next step is to get the simplest molar mass from this empirical formula. What does that mean? If this were the formula of this compound, what would its molar mass be? It would be 2 times 14 for the N plus 5 times 16 for the O. That's 28 plus, open bracket, 5 times 16, close bracket, equals 108 grams per mole. That is the simplest molar mass. So now we are on step 3. We need to compare the simplest molar mass with what we've been given as the true molar mass and find the factor by which they are different. So we see that they are not the same. This is the true molar mass. This is the simplest molar mass. They are not the same number as one another. So by what factor is this true molar mass greater than the simplest molar mass? We find that out by dividing the true molar mass, 324 grams per mole, by the simplest molar mass, 108 grams per mole, to get the factor by which the true molar mass is bigger than the simplest. 324 divided by 108 is 3. So this is 3 times greater than that. You can anyway see that. 8 times 3 is 24, and 100 times 3 is 300. So that makes 324. The final step is then to use that factor, 3 in this case, to inflate, to increase the empirical formula to get the true formula. So we must multiply each of these small numbers by 3. So N, 2 times 3 is 6, O, 5 times 3 is 15, N6, O15. That is the true formula of this compound.